All right, so time to take a look at our next topic for the unit. We're looking at integration by parts. So before I get into what integration by parts is and what the formula is, we're going to talk about where it comes from. So if you were to take the derivative of a product of two functions, we know we would use the product rule. So derivative of the first times the second function plus derivative of the second function times the first. So we know that. So let's take a look at where the integration by parts comes from by kind of solving this and changing a couple things. Not really solving it, but we're just reordering things and looking at it a bit differently. So we're going to go backwards. So if I multiply through this entire equation by dx, we're going to get rid of the dx. So we're multiplying both sides by dx, and we are going to end up with, let's see, we get a d, oops, that is terrible, d uv, so dx goes away, and du v times v, and then plus dv times u. Okay, so we got rid of the dx on both sides. Now if we integrate both sides, so we're taking the integral of the right side and the left side. We can do that, so that would drop out this off, and we would end up with uv. And I'm going to clean this up and rewrite it, split it into two integrals. So we have the integral of v du plus the integral of u dv. All right, so now if we rearrange this and we subtract the integral of v du to the other side, we end up with this formula here. So u dv equals uv minus the integral of v du. So this right here, this is what we end up with. We have the integration by parts formula that we're going to use. So the integration by parts formula is useful when we are trying to take the integral of something that we really don't know how with any techniques that we know so far. So let's get into one problem, and we'll do some videos of some increasingly harder problems, because there are easy ones and there are hard ones. All right. So here's our formula we just found. Now we know where it comes from. So if you ever forget it, you can just think derivative of product rule and kind of unravel it that way. So the key here, so if I tried to take the integral of x cosine x with anything that we know so far, can't do it. So what we're going to want to do is we're going to identify a u and then identify a dv. So, and the more you run through these problems, the easier it's going to see what needs to be your u and what needs to be your dv. So the way I like to think about it is most of the time you're going to want to take your part of the function that if you were to take the derivative of, you would eventually get to a constant or a zero. So in that case, we're looking at x. Our x is going to be our u. So I'm going to write out u is x, and then this rest of the formula here, not the formula, the function that we're trying to integrate, is our dv. So our dv is cosine x dx. Okay, so now the key here is we need to find a du, So derivative of x is just dx. Derivative, or we have dv, so we need to find the antiderivative to get to a v. So antiderivative of cosine dx is sine dx. Or sorry, sine of x. Alright, so pick a u, pick a dv, that's 2 steps. And then we take the derivative of u and then the antiderivative of dv. So once we have all 4 pieces, now we can start plugging things into the formula where they go. So this equation right here, this is our integral of u dv. So this is going to equal our u times v. So let's put that in. So u is x and v is sine. So x times sine x, okay, minus the integral of our v du. So a v is sine, and our du is dx. So the purpose of integration by parts is to get it to where we can integrate something. So we look at the integral that we have here. We have the integral of sine. We know what the integral of sine is. The antiderivative of sine is negative cosine. So we go ahead and we integrate that. So we get x sine x minus a negative cosine, so that's plus cosine plus c. So that would be our final answer there. So we took the integral of x cosine x, and we ended up with this. So just to double check, if you were to take derivative of our answer here, our x sine plus cosine, we should end up back at x cosine x. All right, so that's it for this video. Keep an eye out for other videos. I'm going to make some with some harder problems.